in this video we are going to perform the time shifting operation. We're going to perform the time shifting operation. Now, the time shifting operation is represented by an expression x of n minus a. Now, what this does to a particular signal is that it changes the location, or let me say the position of each of the samples in the time domain without influencing the amplitude the of the samples. So now you can have two instances when this um, constant or this variable a here can be what? Greater than 0. That is when it's positive integers. Now when it's positive integers, you are going to um, shift, you are going to shift towards the right. You are going to shift towards the right. Good. And this is going to lead to what we call time delay. It's going to lead to what we call time delay. Now, time delay is when maybe a particular signal you were supposed to see it, or you were supposed to experience it maybe at, let me use timing, let's say at 7 a.m. and later you are seeing it at what? 8 a.m. You see, it has been delayed by 1 hour. A practical example can be with the microphone. Let's say you speak through a microphone and you were expecting that through the speaker it should be heard at the time you spoke. But if there is a delay, it will be heard some time later. Is that okay? So that is what we describe as time delay, and that occurs when you have the integer to be a positive integer. Now, when you have a negative integer, that is a less than 0, your samples are going to shift. Your samples are going to shift towards the left. Your samples are going to shift towards the left, and we term that as time advancement. We term that as time advancement. That is what time advancement will occur when maybe the sample you were, maybe you were expecting it like at 2, let's say you're expecting something at 2 p.m. and then it happens around 1 p.m. You see that it has kind of reduced your waiting time, but we term it as a time advancement. The sample appearing earlier than you expected it. And that occurs when you have the a to be a negative integer. So in that case, the expression x here will now turn to something like x of n minus a, right? And we know this will give us x of n plus a, right? So whenever you see maybe x of n then a negative, just bear in mind that you are going to shift towards the right, and it's termed as what? Time delay. When you see it like, let's say x of n plus a, you are going to shift towards the left. So let's solve this example. Let's solve this example with what we have just said. So the first sketch we are going to sketch x of n minus 2. X of n minus 2. So let me label the axis 0, 1, 2, 3, 4, 5. -1, -2, -3. All right, so if we are going to shift now, n minus 2, as I told you earlier, we are going to shift towards the right, and that is what? A time delay. So each sample here is going to move by 2. It's going to move 2 places towards the right. So the sample at 1 here will move to what? 4. Remember, amplitude is going to remain the same. Now the sample at 0 here, remember at position 1 here, it is 0. So we can leave that out, or even if it moves 2 places, it will now be at what? 3. The sample at 0 will move to 2, and the amplitude will remain the same as what? 4. The sample at -1 will move to what? +1 with an amplitude of what? 3. with an amplitude of 3. Right, so now let's do the second one. The second one, we are going to sketch. So this is I, and this is I. We are going to sketch x of n plus 1. Right, so x of n plus 1. So 0, 1, 2, 3. -1, -2, -3. That's okay. So positive, our integer here, n plus 1. Anytime you see n plus whatever integer it is, know that you are going to experience time advancement and the whole samples are going to shift towards the left. So if it is 1, we are going to shift each sample to the left by a place of 1. So the sample at -3, if it moves to the left, it will come to what? The sample at -1 will move to what? -2. And the amplitude will remain the same, 3. The sample at 0 will move to what? -1. And the amplitude will remain the same, 4. The sample at 1 here was 0, so it will move, it will be here, 0. The sample at 2 will move to what? 1, right? And the amplitude will be the same, 1. All right, so this is how we perform the time shifting operation. Remember, um, when you have, let's say, x of n minus a particular number, you shift to the right. When you have n plus an integer, you shift what? To the left.